Have you ever pondered the shape of our Earth? Is it as round as a basketball or as flat as a pancake? An intriguing question, isn't it? This age-old debate has given birth to two main theories. The round Earth theory, widely accepted and scientifically backed, and the flat Earth theory, a perspective held by a minority yet fascinating in its own right. What makes some people believe in a flat Earth, you ask? In this video, we're going to dive deep into these theories and see which one holds up under scrutiny. Flat Earth theories have been prevalent since ancient times. But what exactly do these theories propose? Well, at their core they suggest a radical departure from what we know through modern science. Flat Earth theories posit that our planet is not a globe spinning through space, but rather a flat disk, stationary and unmoving. Imagine, if you will, a large coin floating in the void. That's essentially the model proposed by flat earthers. Surrounding this disk, acting as a barrier, is what they describe as a massive ice wall. This ice wall, they argue, is what keeps the oceans from spilling off the edges of the Earth. They also reject the notion that gravity pulls everything towards the center of the Earth. Instead, they propose that the Earth is constantly moving upwards, creating the illusion of gravity. These theories might seem outlandish, but they have a surprisingly large number of followers. So, where do these ideas falter? Let's start debunking flat Earth theories by talking about the curvature of the Earth. Perhaps the most tangible evidence of Earth's curvature is the way ships disappear over the horizon. Picture this: you're standing at the shore, watching a ship sail away. Initially you see the full vessel as it embarks on its journey, but as it moves farther away, it doesn't just become smaller until it's a tiny speck in the distance. Instead, it seems to sink into the sea, starting from the hull and eventually leaving only the top of the mast visible. If the Earth were flat, we would be able to see the entire ship, until it becomes too small to discern with the naked eye. But the fact that the ship appears to sink shows that it's moving beyond the curve of the Earth. Another compelling piece of evidence is the round shadow Earth casts on the moon during a lunar eclipse. A lunar eclipse occurs when the Earth comes between the sun and the moon, casting a shadow on the moon's surface. This shadow is always round, no matter what angle or time we observe the eclipse. The only shape that always casts a round shadow, regardless of its orientation, is a sphere. If the Earth were a flat disk, as flat Earth theorists claim, it would cast an elliptical shadow most of the time. But that's not what we observe. Every lunar eclipse shows us a round shadow, signifying that the Earth is spherical. These two examples are just a fraction of the evidence supporting a round Earth. The way ships disappear over the horizon and the round shadow cast on the moon during a lunar eclipse are observable phenomena that anyone can witness without needing sophisticated equipment or advanced scientific knowledge. They're simple yet powerful reminders of the Earth's curvature. As we can see, the curvature of the Earth is a hard fact to ignore. The curvature isn't the only evidence of a round Earth. Ever wonder why we have different time zones? Let's delve into that. The concept of time zones is a fascinating one. It was established to regulate time across the world, based on the Earth's rotation. If the Earth were flat, the concept of time zones wouldn't make sense. Here's why. The Earth rotates on its axis, causing the sun to appear to move across the sky, bringing day to different parts of the world at different times. This rotation is what gives us time zones. If we were to imagine a flat Earth, we would need to reconsider this concept entirely. In a flat Earth model, the sun would have to be directly above every location at the same time for there to be daylight everywhere simultaneously. But that's not what we observe. We see that when it's midday in New York, it's nighttime in Tokyo. This stark contrast in daylight can only be explained by a round Earth, where different regions face the sun at different times due to the Earth's rotation. Next, let's talk about the cycle of day and night. The Earth's rotation is also responsible for this phenomenon. As the Earth spins, different parts of it are exposed to the sun's light, creating daytime, while the parts not facing the sun experience nighttime. This cycle would not be possible if the Earth were flat. On a flat Earth, we would expect daylight and darkness to occur everywhere at the same time, which is not what we observe. The sun rises in the east and sets in the west, and the cycle of day and night unfolds gradually across the globe, not all at once. This gradual transition of light and darkness across the planet is further evidence of Earth's spherical shape. In conclusion, the concept of time zones and the cycle of day and night are not just random occurrences. They are phenomena intricately linked to the Earth's rotation and its spherical shape. Time zones and the cycle of day and night are compelling evidence that the Earth is round, not flat. So, having debunked the flat Earth theories, what can we conclude? We've taken a deep dive into the world of flat Earth theories, exploring their origins and the arguments they present. We've also journeyed through the robust scientific evidence that overwhelmingly supports the notion of a round Earth. From the way ships disappear over the horizon, to the differing constellations visible in the northern and southern hemispheres, and even the images of our blue planet taken from space, the signs of our Earth's roundness are all around us. But this discussion is about more than just the shape of our planet. It's a testament to the power of critical thinking and scientific literacy. In an era overflowing with information, it's more important than ever to be able to discern fact from fiction, to question what we're told, and to seek out reliable sources of information. The exploration of alternative perspectives like flat Earth theories can indeed be fascinating. They push us to question what we think we know, to challenge our assumptions. But it's crucial that we ground these explorations in scientific facts, in empirical evidence. It's not enough to simply believe something because it's an interesting or novel idea. While it's fascinating to explore alternative perspectives, it's important to ground our beliefs in scientific facts. After all, the shape of our Earth isn't just a matter of opinion, it's a matter of fact.